last type of equation that you have learned in algebra is going to be the quadratic equation. And so it's only fair for us to be modeling them in lesson 7. We have an opening exercise here, a problem where we have the length of a rectangle is 5 inches more than twice a number. In this case, n, my variable is going to stand for a number, whatever that is. And the length is twice more than a number. So my length is 2n plus 5. Now, this is a common student mistake here, and I want to pause a little bit to talk about it. Whenever you have something that's more than something else, whatever comes after the than has to go first. So a lot of students will write 5 plus 2n, and that's completely wrong. It's actually 2n plus 5. And so when something is less than the same number, like the width, then your width is n minus 4. Not 4 minus n. That would give you a completely different answer. Okay, my perimeter is 44 inches, and in here I know that perimeter you have to add all sides together, and I have 2 of each. So you see there that I wrote down 2 times each side. And initially you might think, hey, this only has one variable. Is it quadratic? Well, I don't know. Let's find out. And I'm going to go ahead and first distribute that 2 across both binomials. And then I'm going to combine my like terms. I've highlighted my like terms just so that you can follow along and know what I'm adding together and subtracting together. So I end up with n equals 7. Now, is this a quadratic? Well, quadratics have degrees. And in here, my largest degree is exponent of 1 for the n. It's not raised to a square or a cube. So this would not be an example of a quadratic, but it's a stepping stone, right? Because it has one variable. We want to go ahead and plug in our 7 just to make sure that it works, and it did. Let's look at the second example. It's very similar in the first one. We have a length of a rectangle is 5 inches more than a number. Go ahead and try to do this on your own. Your width is 4 less than a number, and you have an area that's 15 inches squared. Okay, hopefully you try to do this on your own, and that way you're just checking for misconceptions. So I have one side that's going to be 2n plus 5, another that's n minus 4, and my area 50 inches squared. Now I notice right away that I have something raised to the exponent, which is going to be inches squared. And so this could possibly be a quadratic situation. Let's see. I know my area is length times width, so you see me multiplying both binomials there. And as soon as I do that, you see that my n is being raised to the second power. So I don't have that as a common term. My other common terms I've highlighted. I'm going to go ahead and combine them. And I'm going to have the whole equation equal to 0. The reason I do that is because we want to solve this as a quadratic. So I'm going to go ahead and split the line right now. I have a leading coefficient of 2, and that's why I'm choosing that method of factoring. I'm going to go ahead and get the product of A and C. That's going to give me a negative 70. And then I'm going to find factors of negative 70 that will add up to a negative 3. And I find a combination that will do that. If my 10 is negative and my 7 is positive, I will add up to a negative 3. So that's the combination I'm going to pick. When you split the terms, you're just going to keep the first and last term the same. So I have my 2n squared minus 10n and 7n minus 35 on the other side. Group them and factor out the greatest common factor from each group. That's precisely what I'm doing right now. 2n and 7 are my greatest common factor. And then you notice that I have n minus 5. That's the same binomial in both terms. So I have my 2 binomials. Now I can go ahead and solve this quadratic equation. I find the first answer, n is 5. And I find my second answer, n is negative 7/2. Now, because I am applying this to a word problem, this is what modeling is all about, I have to actually check and see if this would actually work for the situation. I immediately find out if I try to use n equals negative 7/2, I'm going to get a negative answer, and distance can never be negative. So that is not a possibility, even though I did solve the equation with this number. It's not a possibility for the word problem. So I actually only have one valid solution, and that's n equals 5. Let's do some more word problems. We have a picture. Most pictures are in the shape of a rectangle. So we have the height that is 4/3 its width. So in this case, my variable that I don't know is going to be the W that stands for the width, because my height is going to be 4/3 of that. Now, what's interesting about this word problem is that it gives me the area of 192 inches squared, but also gives me a ratio of height to width. And so I have to find the dimensions of the enlargement, and the area is basically once it has been enlarged. So I set up my equation here with words, and that's okay. Sometimes you have to do that. And then I'm going to substitute my words for my numbers. And we have basically our length times width equals my new area. And because the ratio is the same, this is going to work for your particular situation. So now I have to get rid of the 4/3. And to do that, I'm going to multiply by this reciprocal. And so when I do that for each side, I'm going to end up with W equals, and this is why I love leaving terms in fractions instead of decimals, because I can just easily divide that up. I have 144 equals W squared. I notice right away 144 is a perfect squared. So when I take the root of W squared, my answer is a plus or minus 12, but this is area, so I know my answer has to be a positive. And I have to actually answer the question. The question is, what are the dimensions of the enlargement? So I do have to go in and find the length, and that would be 16. Why don't you go ahead and try to do the first exercise? It's very similar than the one that I just did for you in model. All right, we have this word problem. We have a rectangle, and the length is 4 centimeters more than 3 times the width. And so you know that the 3 times the width has to come first before the plus 4. And then we know that area is length times width. And the new area is 15 centimeters cubed. So we have the width times 3W plus 4. And that gives us a trinomial that we have to go ahead and factor out. I have a leading coefficient that's not a 1, so I would definitely choose the splitting the middle or splitting the term method. I'm going to multiply 3 and my negative 15. And then from that product, which is a negative 45, I'm going to find factors of negative 45 that are going to add up to a positive 4. So I found 9 and 5. And I know that if my 9 is positive and my 5 is negative, I'll actually end up with a positive 4. So now I have to rewrite the whole thing with an expanded form. And I'm putting my positive 9W and negative 5W. I'm going to group this so that I can factor out my greatest common factor in each group. My 3W is the greatest common factor in the first group, and a negative 5 is a common factor in the second group. And then you notice that I have now my two binomials, 3W minus 5 and the W plus 3. So I have my two equations. I can go ahead and solve for W. Now remember, now that we're modeling, we're actually applying this to a word problem. So once you have your answers, you have to check them. And immediately I see my first answer, W equals negative 3, cannot work, because distance cannot be negative. So that's not a possibility anymore, even though it works to solve the equation. So my only possible answer here is 5/3 for the width. And then you can use that to figure out what the length is. Did you get it? I'm going to go ahead and give number 2 a try. We have a very interesting problem here, because they give us the ratio of length to width is 2/3, and then they give us the area is 150. So we don't know the measurements, but we do know that the length is 2 times something, and because of the ratio, the width is going to be 3 times that same something. So I automatically just pick any variable, and here I've picked n, written my equations, and then figured out what n is. So n squared is 25, and so n can be either plus or minus, but because we're dealing with area, n can only be positive 5. And I found my length and my width here, and they do have the ratio of 2 to 3. So it works out. This definitely was not the most complicated problem, but you will see problems like this in class.